In this video I am going to work through two types of titration calculations related to this neutralisation reaction as shown here. This is the acid, hydrochloric acid. This is the alkali, calcium hydroxide. This is the salt, calcium chloride. And obviously this is water. So in this reaction we have the concentration of the acid as 0.4 moles per decimeter cubed, and for the alkali there is 80 milliliters of concentration 0.6 moles per decimeter cubed. So for part A, we need to use the equation concentration C equals N, the number of moles, over the volume, and then rearrange this to make N the subject, so the number of moles is given by the concentration times the volume. Therefore, the number of moles of the alkali present equals its concentration of 0.6 times its volume in decimeters cubed. Now 1 decimeter cubed is the same as 1 litre or 1,000 milliliters. So we need to divide the 80 milliliters by 1,000 to convert it to decimeters cubed. So that gives the number of moles of the alkali as 0.048. Now looking at the balanced equation, we need to look at the ratios. So we're looking at the ratios of the reactants. So we've got HCl and calcium hydroxide. And then the ratio is going to be 2 to 1. And I've just worked out the number of moles of the alkali, so that's 0.048. So that needs to be doubled to get the number of moles of acid required. So that's going to be 0.096. So that's the ratio of the moles. So we can say that the number of moles of the acid present equals 0.096. Now if we make V the subject of that formula, we have V equals N over C, number of moles over concentration. So that's going to give 0.096 over the concentration, which is 0.4. Therefore, the volume of the acid required equals 0.24 decimeters cubed. Now to convert this into milliliters, you need to multiply it by 1,000, so 0.24 times 1,000 gives the volume of acid required as 240 milliliters, and that's the answer to part A. Now for part B, the mass of the salt dissolved in solution needs to be calculated. So we're going to look at ratios again. So we've got ratios, this time of the alkali and the salt. So in the equation it's going to be 1 to 1. and the number of moles of the alkali was worked out to be this. So the same number of moles of the salt must be in solution. Now, there's another equation which needs to be used in this case. So the number of moles N equals the mass over the relative formula mass. So if we rearrange this equation, because we require the mass, so that's little m equals the number of moles N times the relative formula mass Mr equals, so the number of moles of the salt is 0.048, and now in brackets the relative formula mass of calcium chloride needs to be calculated. So the atomic mass of calcium is 40, then we've got 2 chlorine atoms, so we've got 2 times. Atomic mass of a chlorine atom is 35.5. So this gives a mass in grams of 5.328 grams. And this is the answer to part B.